So now we begin to do the homework set for chapter 11.3, and I'm going to start with number 2 of your homework. And what it's looking like is it gives you a graph and it asks you to tell what kind of relation do all your variables have. So I'm going to just really roughly sketch this, but oops, it's just a line. That's what the graph gives you. So when you're thinking about the types of relationships that we were looking at before, we had either an inverse relationship or an inverse variation, or we had a direct variation. And one thing that I did want you to take note from in that video is that a direct relationship or a direct variation will take on the graph of a linear model. So something like this. So number 2, the answer is direct. Number 3, I'm also going to do with you. It looks like this. Okay, so this is the type of model or graph that they're giving us, and I'm going to ask you again, is it inverse? Remember, inverse looks something like as you increase your x values, what happens to the y values? Well, it gets smaller and smaller. So it's getting smaller and smaller on that end. As you get smaller with your x values, it's going to be getting larger and larger. So that would be something where you would have an inverse. Number 3, that's not inverse. Okay, and it's not a line either, so it's not direct. So this one, we would write neither. All right, the next set of problems that I'm going to do number 12. And what they say, they give you two variables, an x is 3 and a y is 9. And they say that the variables x and y vary directly. So we know x and y vary directly. So keep in mind what directly means, and you're thinking, all right, directly will take two types of variables and will it either multiply or divide? And remember, directly is the quotient, it's the division. So I'm going to go ahead and say, well, y divided by x is equal to some sort of k. So you want to figure out what is that k in this instance. And by the way, this is in one of your examples. You can always refer back to example 1 in your textbook. Example 1 on page 656. Okay, so here I am going to plug in my values. We have 9 divided by 3 is equal to k, and so therefore k is equal to, what is it? Is equal to k, or k is equal to 3. So knowing that, what we can do now is the relationship of this. You know that as you plot this graph, there's all these other xy values that could be plugged in. If I chose, let's say, x equals 4, well, you would know by this equation, what would y be then? Y would be, let's look at this, y over, and then we have 4 equals, and then we've solved our k, which we're saying the constant that links our x and our y is 3. So if I wanted to just simply solve for this, we would get y is equal to 3 times 4. So because we would multiply 4 to both sides, so we would get 12. So y would be 12. So what's happening here is you're going to go over 3 up 9-ish. Okay, so something right about here. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. This one, if we went over 4, we would go up 12. Do know that this will be proportionally growing as well, so it's going to be looking something like that. But your equation for this line, once again, your overall, you're going to say y divided by x is equal to 3. There's your inverse relationship. It's linking your y and your x as some sort of constant. If you wanted to, if you're more comfortable, you could also write it like this. Whoops, y equals, and then multiply x to both sides, 3 times x. Okay, so either one of these will work. Those both signify that y and x vary directly. All right, number 34. I'm going to do that with you. 34 gives you this, y equals 3 over 2x, and they ask you make a table for the values x equals 1, 2, 3, and 4, and then sketch the graph and decide whether x, y vary directly or inversely. So I'm going to start by making my table. So here we have x is 1, 2, I should have just said this to begin with. Alright, so if x is equal to 1, what is y equal to? So I'm going to start by doing this. When x is equal to 1, y would be equal to then, this would imply that y equals 3 over 2 times 1, which is just, if you do that in your calculator, 1.5. Or you could leave that as 3/2. Or you could also change that as a mixed number and write it as 1.5. Okay, 2, when x is equal to 2, this would imply that y is equal to 3 over 2 times 2. I'm just plugging it strictly into this relationship that we have going on, and we're trying to discover what is it going to be. So 3 over 4. 3 over 4. If you do that in your calculator, it's going to be 0.75. So x equals 3. Okay, we're going to have y is equal to then 3 over 2 times 3. This is going to get us 3 over 6. So we're going to get 1/2, which is 0.5. Okay, and then x equals 4. That would imply y equals 3 times 2 over 4. So 3/8, which is approximately 0.125. So now, if you were to graph this, I'm going to make this pretty small. I'm going to go by, 0.25s, how about? So 0.25, 1.25, and 1.5. Okay, and then I'm just going to go by 1, 2, 3, 4. So please do label your table and do it somewhat carefully here. So I have 1 goes up to 1.5, that's this plot point right there. 2 is going to vary with this y value, it's 0.75, so it's right here. Go over 3, we're going to go up 0.5. You can see as I'm increasing these values, as x is increasing, what's happening is the denominator is getting bigger. So it's getting 3 over a bigger and bigger number, y is getting smaller. So here is what we have. So is this now an example of direct or inverse? What does it look like? And look at here too. What we do have is if you wanted to, you could multiply x to both sides and you get y times x is equal to 3 over 2. So there's a couple ways to look at this. Here, when you chunked those all together, you got your two variables together. It's a product. So that suggests right there inverse relationship. When you graph it, that also is an inverse relationship. You can see this happening as x is getting larger, your up is getting smaller and smaller. So that is an inverse relationship. Alright, 39 is a base and a height problem. That's like what we had with that visual that we started with. So the area B of the base and the height h of a prism with a volume of 10 cubic units are related by the equation BH equals 10. And it says state whether the variables have a direct variation, inverse variation, or neither. Right here are variables. You can see this. Try to think about prisms. I can't draw prisms very well. Something like this, kind of. Okay, so there's the prism. Here's your base. Here's your height. That height would be kind of going right down the middle. Height of the pyramid or prism that you have. There's your height. Okay, if this were a volume, let's say 10, all right, we filled that. But now, what if we made our base bigger? So here we have this bigger base. So this pyramid is going to stretch out and it's therefore going to cover kind of more volume capacity. Then it's not going to take that full prism. If this base is bigger, it's not going to take that full prism to fill with that 10 cubic liters or cubic units, whatever you kind of have as your volume units. It's only going to go so far as that height maybe. So there is your height. So what you are seeing is, first of all, product. Okay, second of all, if you can visualize it, then what you're going to be seeing here is we have an inverse relationship. So inverse variation is what you would write down as your answer here. Okay, so you're going to be thinking through those. All right, that's it.